My name is Razieq. I am a student of Computer Science, Data Communication and Networking. Today I'm going to present about my FYP project entitled Smart Room Utility Management, or in short, SRAM. Short introduction for my project is that the Smart Room Utility Management is an IoT-based system that implements temperature, humidity, light intensity, and motion sensor to create an automatic system for electric appliances that commonly found in a room. A website is used to gain control over the hardware and also provide a cloud service for storing data that is collected from the sensor and also interpret it in a form of graph. Using the data, it can be made analysis and we can also monitor room condition from the data. The objective from this project is to develop a smart light and fan system using a microcontroller with Internet of Things IoT and also cloud system that can automate LEDs and fan as well as give efficient management of the electrical appliances. For example, the automation is depending on the room condition. For example, if the room is too dark, the system will automatically on the light system for the room. Uh, and if the room temperature is high, the fan is automatically turned on. The cloud system is used to store the data and also to facilitate the data transfer from the hardware and to the website. And for the second objective is to evaluate the performance of smart light and fan system using network performance testing and functionality testing. The scope of this project is to implement the use of Internet of Things technology in developing smart room utility management. The second one is to implement cloud system in storing useful information and website to provide control over device. By using cloud system, it enables the system to have virtually unlimited storage for data and also can provide monitoring for the data and send the data over the website for users to look at. And for the website is for every user to gain access to the system whenever they are, wherever they are, as long as they have the internet connection from their devices. And the third scope is the project's allocation is for the classroom and cafeterias in University Teknologi Mara, Cawangan, Melaka Kampus Jasing. The methodology that implemented in this final year project is software system development life cycle, agile method, and data analysis. The reason I choose agile method is because it's enable me to change the content of the project whenever I see fit during the development process. And for data analysis is for me to search for useful information from survey, journal, article that are involved in this project. Next, I will show you the demo of the project. For the first demonstration, I will show about the website. This is the homepage of the website of the SRAM system. In the homepage, it tells a little bit about the SRAM system on how it can control the light fan and how it can be accessed from anywhere, and also it is incorporated with TeamSpeak. I will log into the system. First, I will log in as admin. and enter the password. After logging in, the website will take us to the home page earlier. Next is for the IoT control page. In this IoT control page, we can click the light on and off button and also the fan on and off button to enable us to on and off the light and fan. And also it can be made to on the auto mode and notification mode. Below is show the status of the light and fan, on also auto mode and notification mode. The purpose of this notification status is that when other user is using the system, it will update to the TeamSpeak. And if another user is using the system, if the data from the TeamSpeak will be updated here so that the user can know the current state of the room appliances. Next is the graph that shows the data collected from the sensors and also the input that the users made. For example, on and off button of light and fan, automation mode, and notification mode. Only admin can have the ability to on and off mode, notification mode, and also see this graph for monitoring room condition and also monitor the action of its user for how long they use the devices. Next is the sign up button. Only admin can have the access to sign up new users to the system because not everyone have the ability can be accessed to the system. Hence, admin can only admin can register for the security purpose of the system. The users page shows the users that have been registered into the system. First is the admin, and the second is the normal user that the admin can delete when the user is not active anymore. So I will log out from the account and shows the normal user account. After logging in, it will show the home page, the same with admin. I also have the IoT control page, but it is limited only for the light and fan on and off button and also auto mode function. It does not have notification mode. It also have the status mode, but does not shows the graph for monitoring room condition and to know the action of users that have been made in the system. That's all for the demonstration of the website. For the next demo, I will show the on and off function of both the light and fan. Firstly, we on the light button on. It will take a bit of time, 15-second lag time, because of TeamSpeak service. The free service offers 15-second lag time for every input of data, but if the paid version only have 1 second lag time, so it will take 15-second time to on and off the light. So next I will off the light. As you can see, it take a bit of time and the light is off. Next I will on the fan. As you can see, the fan is on. Next I will off the fan. So as you can see, the fan is off after clicking on the button. For the next demonstration, I will show the video that I've taken to describe more about the automation system of light. So we'll play the video. Firstly, to initiate the automation, we must have the motion sensor sense our motion. So here, as you can see, the fan is turned on because the temperature is over 30. Next, I will turn off the light in the room. After a while, the light system will automatically turn on. As you can see, the light is turned on because the room is because the room is dark. So I turn on the light on the room. The motion must be detected. As you can see, the light is turned off after a little bit of time. The fan is still turned on because the temperature does not change. It is over 30. So that is all for the demonstration of automation of light. For the motion sensor, the detection of motion must have no motion in the duration of 2 minutes. If the system detect that there is no motion in 2 minutes, then it will turn off all of the devices, fan and light. That's all for the demonstration of the automation light. For the next demonstration, I will show how the fan auto mode works. I will play the video of the fan auto mode. When enabling auto mode for fan, it must detect motion. As you can see, the fan is not turned on. This is because the temperature is 30. In order for the fan to turn on, the temperature needs to rise to 31 degrees Celsius. Hence, I like a lighter to increase the surrounding temperature in the system. The increase of temperature for the system will take a little bit of time because the sensor will sense the temperature rise gradually from the current 30 degrees Celsius, increasing from that point. Hence, it will give us a lag time before the fan is turned on. After reaching over 31 degrees Celsius of temperature, the fan is turned on automatically by the system. This can be shown by the graph. Here we can see that the graph is gradually increasing, but the gradually decreasing in a very slower rate. Hence, when the temperature gone back to below 31, it will turn off the fan, but it will take a longer time than to turn on the fan. As you can see, the fan is turned off because of the surrounding temperature is back to normal at 30 degrees Celsius. That's all for this demonstration. The next demonstration, I will show about the notification function that have been put in the website. For the notification mode to enable, the notification mode must be enabled by the admin, and the light must be turned on, and also there is no one in the room. That is the requirement for the event to be triggered. So I will play the video for the notify mode. Firstly, I have lowered the sensitivity of the motion sensor in order to detect no motion. So I have opened on the light and on the notification mode to enable the notification mode to detect for a person, a motion in the room. When the light is turned on and the sensor detects that there is no one in the room, it will send an email to the admin because it triggers the event that has been created using the ThinkSpeak account. So we can see the email from here. Using the webhook via IFTT services that is connected to the ThinkSpeak account, and from this we can know that the light is not switched off. So admin can know that there is no one in the room, but the devices are turned on. So the admin can turn off the devices using the website. That's all for the demonstration of the notification mode. We come to the last part of the video, which is the conclusion. For this final year project, it has some limitation and also have ways to overcome that limitation. The first limitation is that the ThinkSpeak offers 15-second lag time for every data that has been submitted into the ThinkSpeak, or every data that has been updated to the website. This will give an undesirable lag time for users when using the system. But 15 seconds is not a very long time, but it can be improved to only 1 second by subscribing to the paid version of ThinkSpeak account. By using the paid version of ThinkSpeak account, the lag time is greatly reduced and it will greatly improve the performance of the system. Also, it provides more channel and we can add more sensing for the ThinkSpeak account. We can also add multiple rooms to be monitored and to have the same system like the smart light and fan system into the rooms. Other than that, the second limitation is the motion sensor. The motion sensor must be catered by the surrounding environment. For example, if the surrounding environment have little motion or little people coming to the place, the sensitivity of the motion sensor must be increased. If the place environment is full of motion and many people come and go, the sensitivity of the motion must be reduced in order for the system to work properly without fail. That's all for this final year project demonstration. I'll be awaiting the question and answer session from the examiner. Thank you for watching this video.